So remember that these biogeochemical cycles are showing how the nutrient, in this case carbon, moves from the different spheres, from the biotic sphere to the abiotic realms. We can see how it moves between the atmosphere and the ocean and solid rock. So we're talking about phase changes as well. This one shows dissolved CO2 going into the ocean on the left. Remember, that is called ocean uptake. You know carbonic acid, right? That's the same stuff that's in our pop. So as the earth heats up, as we pump more CO2 in the atmosphere, the oceans are working overtime to convert that and contain it. And unfortunately, that's creating that problem of ocean acidification, which is eating away at those calcium carbonate organisms. So that's a big problem. I had you look up several rocks. We don't get to spend much time on rocks or minerals in this class, but coal is a very important one. It forms in swampy areas from mostly plant material that decays. The other important carbonate rock is limestone, calcium carbonate, and it forms from marine organisms in shallow waters usually. Now, one of the things I asked was, why is it so important for Indiana? Well, we have limestone bedrock, and our limestone is such wonderful quality that it has been mined and shipped all over the world for buildings. It's in some very famous structures. You've probably heard of these. It's on the facade of Yankee Stadium. It is the main stone used on the front of the National Holocaust Museum in Washington, D.C. It is obviously in our state capitol. It is most of the buildings on the campus of IU Bloomington. And the most famous building, especially at the time that it was constructed, over 10 million limestone bricks that were used to make the outer shell of the Empire State Building. When we look at these cycles, we're not just looking at living and non-living and how it moves back and forth. We are looking at how it goes into different phases as well. So there again, you see the major greenhouse gases, carbon dioxide and methane. I had asked at the very end of yesterday's quiz, or how have humans sped up the carbon cycle? And the third one I asked was large scale or industrial farming. And when we raise livestock in large amounts, cattle, pigs, chicken, their waste is loaded with methane. That's what human waste is too. So methane is given off in huge quantities in their bodily waste. And then that can get in water as leaching occurs from runoff. It's a huge problem, because thinking about that, if you have 1,000 cows, and it's usually even more than that, and all of them are having a lot of waste each day, what happens to all that? Well, it can absolutely devastate an environment. We already talked about limestone, calcium carbonate. Remember that reacts with acid. I don't know if you knew that, but all carbonate minerals or rocks, marble is another one, they eventually wear out. Think about ancient Greece. A lot of those buildings, the Colosseum, the Parthenon, they were built out of marble, which is very common in that area. And over time, over thousands of years, they start to wear down, especially as our rain becomes more acidic. Indiana has a lot of caves in the south, and those are all formed by acidic groundwater flowing through cracks and opening up these giant caverns, these holes. So Kentucky, Tennessee, anywhere with limestone bedrock is going to have huge underground caves. And finally, we see the liquid form of carbon. That's the formula for carbonic acid, which we already said occurs simply by the ocean absorbing it. Now, the most important thing up here are those two equations at the bottom. Now, I've always told my kids, if you're not good at memorizing stuff like this, think about what you do. You breathe, you respire, respiration. And what do you need? You need oxygen. So if oxygen is on the left, then you know it's respiration. If oxygen is on the right, then it's photosynthesis. If you can remember just oxygen, you're good to go at recognizing it. Or think about what a plant needs. A plant takes in carbon dioxide. It needs water and sunlight. Those are the reactants. CO2, water, sunlight. What does a plant make? Sugar, and it gives off oxygen gas. Free oxygen, which is important, because that's what we need. So these two equations mirror each other, right? They're working in tandem. They're their own miniature biogeochemical cycle.